Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Enhanced Spectrum Access Scheme with External RF Energy Harvesting for Cognitive Radios. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the research domain in which we are working on that is the energy harvesting in the cognitive radios. So this is basically harvesting of the energy for the spectrum scanning in the cognitive radios. So before moving toward the video, let's talk about that what we will cover into this video. In this video, we will initially talk about the application areas in which this developed system can be used. Further, we will talk about whatever the code we have designed, how to execute, and what software requirements are there. Then we will talk about that what current systems are doing into the same domain and what are the problems identified, and an overview to the proposed scheme, that what we implement, how we implement it. And finally, the software simulations, outcomes, and results will be discussed. So let's talk about the application areas. So spectrum sensing is basically specifically designed for the cognitive radios. So before moving to the application area, we must know that what exactly the cognitive radios is. It is a form of the wireless communication in which transceiver can intelligently detect which communication channel is in use and which are not. So that once the channel is free, they can just uh, transfer the traffic from one section to the another where it is required in an emergency case. So let's talk about the application areas. So there are certain application areas where the cognitive radios can be implemented. It can be in the unmanned area vehicle systems, in air to air communication, air to ground communication. Being more specifically, these can be implemented in certain sections like fire services, transportation, biomedical engineering, disaster relief, medical services, and all. But why cognitive radios? Why other any wireless communication cannot be implemented in it? So why it is that important? So basically, all these application areas are using the cognitive radios in the scenarios when we do need the any emergency network, or we do need any confidential network where like military, multimedia channel, cellular network, or leased network where there are certain requests for the certain users of the band for the communication purpose, right? So there in that particular scenario, this developed system can be implemented. Now the challenge is like what exactly we are doing, what is the issue in that? So the issue is like sensing of the spectrum and assessing it. So in order to assess the spectrum, the system has been developed. Most of the people are working in the domain of like only sensing, so we are working in the access. So let's see how the code is to be executed. In this particular section, the code folder will be given to you in which these files are there. The whole code is developed in the MATLAB, so you must have the MATLAB software with you. The MATLAB version that we are using here is MATLAB 2019, so you can use 15 or above, but make sure it should be a full version. To run the code, you just need to copy the path or the folder where the code is placed and go to the MATLAB and just paste the path here and press enter. When you will press enter, all the files available in the folder will be shown here in the current folder. Now we do have 4 files: case 1, case 2, case 4, and different cases. So these are basically the scenarios which we have implemented in order to compare it with the base paper. So to run this code, you just need to select the file whatever you want to execute, and you need to click on the run button here on the green play button. When you will click on the green play button, it will start executing. So before moving to execute the code, let's talk about that what are the current system and problems and what we have implemented. In the current system, mostly We are following the paper. This is one of the paper that we are following for the scenario. So this was the system that was designed in order to develop a hybrid spectrum access scheme in which energy harvesting is the major concern. So energy harvesting, why it is important? Energy harvesting is important because in order to perform the transmissions, there should be energy efficiency and easily the data can be transferred. So but because there are certain different users in the network, so in order to harvest the energy there should be some strategy. This was the paper that they have given for this particular task, in which they have considered the scenario in which there were primary users, transmitter and receiver, and CR, that cognitive radio and transmitter and receiver, and there is one node SR which was harvesting the energy from these users as per the request. So what they have proposed one relay node to introduce in the network, which was SR, which is harvesting the energy. But other than that, there is some the problem that we identified is in some of the scenarios when there is the depletion in the energy, then if primary user or seer cannot be able to harvest the required threshold energy, then what how they will start it? Obviously the communication will get closed. So in order to handle that issue, what we are doing, we are introducing some random external source of the power, in which if they are not able to extract the enough energy, they are not able to harvest the energy. In that scenario, they will request the external energy source to fulfill that. So inspired from that, we have designed the whole system. So let's run the code first. So in order to run the code, we just need to play the button, and when it is started, so you can see what we have designed. We have proposed a new strategy to harvest the energy by introducing two new nodes along with the two primary users and two uh, cognitive radio users, right? So you can see this was the scenario at the initial stage of the base paper that we are following, in which two primary users, one harvester center and two cognitive radios TX and RX is there. Then we introduce the new concept in which two new sources has been deployed randomly in the network. So network dimension are of 100 by 100. So how it is helping, we have developed the scenario in which the energy is harvesting. So this is the SNR detection probability with respect to the SNR. As SNR is increasing, the probability of detection is increasing. The proposed and the base paper results has been analyzed, and you can see the power harvested from the proposed method is more in comparison to the uh, initial stage. So you can see in the initial simulation case, when energy is available with the PU primary user and the cognitive radius, there is no need to go for the external user. But at certain time interval, when enough energy is not available with them, they are going for the external user available and harvesting the required energy. Finally, you can see for the network throughput with the proposed method, the throughput of the network is higher. So the we have implemented the whole code with the different scenarios in which the model considered is from the base paper, as they have also analyzed for the different scenarios. One of the scenarios is by changing the sensing time. Second, the scenario is like they are changing the alpha factor, and thirdly they are changing the scenario where let me show you, which was the initially we have already discussed. So this was the scenario in which initially the network has been implemented, PUs, SR, the areas given the points is generated, they are marked and placed in the network and shown. Randomly two of the nodes has been deployed. Then we have calculated the simulation by changing the SNR. The SNR is varying from -1 to 15 dBs, which is converted to dB. Then for every SNR value, we are running the simulation where the energy is being calculated, then threshold being accepted. Then by the mathematical formulation available in the base paper, we are following that in order to calculate the harvesting of energy for the transmitter and the receiver. The model that we are using here is for the AWGN channel through which the signal is being passed after the modulation, and that at the receiver, and we are applying the energy harvesting concept in order to get the outcomes. So here you can see the traditional method was there, where you have the condition like if the threshold value is greater than 0, the harvested energy is taken. So you can see from the base paper they have given few of the conditions that when the energy harvesting energy is with a certain condition, like if it is within the range, here you can see, for harvesting the energy during the duration, this equation is used in the scenario of H node, and this equation is used in case of H1, where H node and H1 are the cases. Here you can see H1, H0. These are the cases provided by them in the scenario when the network has to harvest energy. So the cases that we are using in the proposed methodology is, I can give the overview. We have written the documents for that also. So you can see in the proposed methodology, the harvesting of the energy is given by these equations, where if primary user is present, energy demand satisfied, then this equation. If not satisfied, then this equation. If do not satisfy, then this equation, depending upon the harvesting of energy from the external. So we have a proper documented work for it. So on that we have proposed method and the base paper method, and then finally on that we are comparing the result with respect to the different SNR with respect to detection probability and all. In the second scenario, what we did, there is a factor name that is alpha, which was in the previous case was put static. So here you can see the alpha factor that we are considering here is 0.2, but in second of the scenario, by changing the alpha from 0 to 1 with the variation of 0.1 is considered, and every simulation is considering the alpha factor as per the values generated. So the simulation analysis has been done for that. So when I'm running this, you can see the new results will be there. In third of the scenario, what we are doing, we are changing the factor name sensing time. So sensing time is being generated here. Here you can see, I will discuss the result for the last case. Here the sensing time has been generated for every sensing time, every time the simulation is being conducted with alpha is equal to 2 and the results has been analyzed. So finally all the scenarios results has been saved in the different mat files, and finally a proper comparison with the base paper is being done. So you can see when the alpha was varying, the result is like this, in which you can see by varying the alpha, only CR scenario, only PU scenario, PU and CR scenario, and the proposed external node involvement for harvesting the energy is shown. So you can see the proposed methodology is having the higher power harvested. Finally, even for the throughput, the proposed system is the highest one. So this is the scenario in which the proposed system is working. So in the different cases, all the three cases has been run and saved, and we have saved the results and drawn it in order to show the results without running the individual file one by one, so that we can compare and analyze the outcomes. So this different cases is just for the result purpose. So you can see a total of number of the files are available with us, in which we do have the individual results as well as the proposed result. Here you can see this is the scenario of the SNR with respect to detection probability. This is the comparison of the proposed with respect to base paper. This is also for the throughput and the base paper. This is for the by changing the here you can see we have changed the value of alpha by changing the alpha analysis. Then this is by changing the alpha of the network throughput analysis. Then this is for alpha at 0.1 network throughput, and all the scenarios we have given into it. In every of the scenario, our proposed method is giving the better results when compared in harvesting the energy and assessing the spectrum access in the cognitive radius. So further modifications are still possible into it. So for that details, you can contact us directly and can get the details. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.